Romy, and this is Introduction to SolidWorks. And let me preface this by saying that this is a very basic level CAD class, so it's best for people that don't know any CAD or have not used SolidWorks before. It's the very minimum basics, basically. So first, what is SolidWorks and why use it? Well, as you may know, SolidWorks is a CAD program that allows you to plan, visualize, design, prototype, run simulations, and create custom parts. And why would you use it? Well, almost 50% of companies use SolidWorks. So if you were to go to a corporate company where you had to CAD, you'd have a greater chance of knowing how to use the CAD program that they use. So you're already a step ahead of a lot of other people. And also, exporting and importing files on SolidWorks is very easy compared to its counterparts like Inventor and Onshape. And they're also partners with FIRST teams. So if your team doesn't use SolidWorks but are thinking about it, you can request a free license from them, and then your entire team can basically have a free license to use on SolidWorks. So let's understand CAD. First, there are the individual parts. These are your nuts, bolts, screws, your 2x1s, 80/20s, all that, the individual parts. And then those individual parts are created into subassemblies. Your subassemblies would be your shooter, your intake, your drivetrain, and then your subassemblies would be assembled together to create your main assembly. That is your full robot CAD. And first, we start with sketches. Sketches are the very first thing you have to do in CAD. And the three main components of a sketch is choosing your plane, your sketch entities, and smart dimensioning. And here's a little video that goes through those three things. And when you first open SolidWorks, this is the page that you see. And in the toolbar above, you see a little page icon with a corner down. You click that and you open up a new part. Once that part's open, you choose a plane to start your sketch on. You have your front plane, top plane, right plane. It really doesn't matter which one you choose. So we're just going to go front plane on this one. And then you go to sketch on the toolbar and then click the sketch button. And then you choose a plane again. And sometimes it goes away, so you just have to click sketch again. And you choose a shape that you want. And then we just choose the center rectangle. You create that rectangle, and then you smart dimension. That's where you put measurements to the sides. You can also change which system measurement you're using. You can go from imperial to metric, but in this example, we just stick to imperial. And if this ever happens where everything goes gray and nothing's visible, just go back to your toolbar and go back to edit sketch. So now we're going to dimension it. And notice how all the lines are blue. That means your sketch is undefined. So by putting a measurement to it, your sketch becomes defined. And you see now the lines on the side, they're now black. That's how you know that your sketch, that part of the sketch is defined. So we want the whole thing to be defined. So we're going to put a measurement to the other side as well. And once you do that, you have a fully defined sketch. So yeah, there's not much to sketches. And if the more intricate of a design you want, the more sketches you would use, the more shapes you would use. And we'll get into that in a little bit. So planes, choosing a plane is not very crucial. You can choose whichever one you want, but choosing a plane is important when creating a loft, 3D sketches, or mirroring assemblies, mirroring mates. And like I said, there's front, top, and right plane. And here's a little video on how to create a plane. It's very simple. So we have this little sketch of a circle. And let's say we want to create a loft. So we need to create a plane slightly above it. And so what we're going to do is go into features. And then we're going to go into reference and then create a little down arrow comes and shows you plane. You have your first reference, second reference, and third reference. Really just need the first reference to create a simple plane like this. And your references are the planes that already exist. So your front, top, and right plane. This sketch was made on top plane, so we're just going to choose the top plane. And there are different ways you can set a plane as well. There's parallel, perpendicular, concentric, at an angle, or at a distance. For this purpose, we're just going to do at a distance and make it 3 inches. And so now you have a new plane that you can now sketch on. So in a little bit, it will show that you can easily sketch on this. You would go into the sketch bar and then start sketching a little. We're just going to choose a plane and then do a quick little sketch. So yeah, that's how you make a plane. It's very useful, like I said, for 3D sketches, which we'll also get into later, and mirroring mates. And we'll also get into that later as well. So sketch entities. These are all the entities you have to create a shape, creating an outline. You have your line, circle, curves, rectangle, perimeter circle, ellipses, slots, polygons, and curves and dots, and text. These 4 I use most often. Of course, you can also use these, but these are ones I find myself using time and time again. So you have your line and circle, curvature, and rectangle. The thing to keep in mind about lines are that you have your solid line and then you have your center line. Center lines are very important when you want to mirror things. And again, we'll get into that in a little bit as well. When you have anything that is dotted, it is not part of your actual sketch. It is not a defined part of your sketch, so it doesn't interfere with any parts that are already there. They're called construction geometry, and they help with just referencing other parts. Okay, and now sketch entities, offsetting. I don't use offsetting very often, but it's still something you should know how to do because it does come up sometimes. So this is a simple 4x4 square, and we're gonna go into sketch and offset it. Click the lines that you want, and you can set a distance for them. And so I think I clicked 0.75, and notice how it's on the outside. I want it to be on the inside. So I'll press the reverse button, and now it's on the inside. And now I have a offset sketch at the end. Okay, and then mirroring components. Mirroring components saves so much time. In this example, it's very simple. It's just one like small shape. But sometimes if you have something like a side panel with a bunch of holes in it, which probably like up to 10, 15, maybe 20 holes that you don't really want to redraw, mirroring saves so much time. So here's an example of how to mirror components. We have the same 4x4 sketch again. And then we're going to go in and make a little rectangle. And then whenever you mirror anything, you need to fully define it. So here I am defining everything, making sure that all the lines are black. And again, that's how you know that it's fully defined, when all the lines are black. And the thing about fully defining is that if you don't define it, later on you can mess up something, accidentally move it, and then your sketch isn't where you want it to be. So now we need to make a center line. And you come down to the line icon and you create a center line down the middle. And now you go into mirror components, entities to mirror, that little rectangle, and then mirror about center line. And so now you have a mirrored component. And now you have linear pattern. Linear patterns are so useful. I use them all the time when creating something like a side panel, which has a lot of holes in it. My team likes to create custom side panels for our drivetrain usually. And with all the holes in it, creating them one by one would be such a pain. You probably lose your mind, but linear sketch pattern makes it so easy and it saves so much time. So right here we have a defined hole at the top, and we want to create rows and columns for it. So we go into linear sketch pattern, select what we want to create it from, and then a distance as well as how many of them. So the distance is 1 inch and there's 5 of them. And then notice how, sorry, let me go back. Over here, the y dimension is 1. So that means that there's nothing coming down here, but the x dimension is 5, so there's 5 going across there. But if you want columns, you can easily just go back into linear sketch pattern and put the x to 1 so that there's no x going down, going across, and then select which circles you want going down. And I set that to 5, and that was 0.75, and I select which ones I want. And notice how the holes go up. You can easily click this little button. Let me go back. No. Sorry. You can easily click that button to reverse it. So now you have a linear sketch pattern. Okay. Smart dimensioning. Like I mentioned multiple times before, it gives a measurement to your sketch. So you have to define every single part, every hole, every line, every curvature, because if you don't, maybe when you're CADing one time, you accidentally move something and you don't really realize. But later on, if you try to get that custom made, or you're looking at the CAD again, you realize that's not what I had made originally. And that's because you accidentally moved it because it wasn't fully defined. And that can create a lot of issues later on. So make sure you fully define everything. And you can choose between imperial or metric system. My team usually uses imperial, so we just stick to IPS. And also, the more precise you set a dimension to, the more expensive it'll be to create that if you choose to get it custom made. So like a lot of teams I know, they like to get their chassis plates custom made at KSC. They like to get it water jetted. The more decimals your measurement has, the more expensive it'll be for them to cut it because they have to be a lot more precise with it. So just keep that in mind if you ever want to create a custom part. And then we have 3D sketches. 3D sketches are very, very useful when you're doing preliminary design or prototyping. It allows you to see what numbers do I need to implement in order for this design to fully work. So this is an example of a shooter. And this is from this year's game as well, last year's game, 2020, Infinite Recharge. And this is for a shooter. We knew that the balls are 7 inches wide, so we have that there. And then we want a little compression so it shoots out. So this one is a little ellipses. That's a little smaller than 7 inches. I think this one's 5, so it's 2 inches compression. And notice how there are different planes on here as well. You have your top plane, and then you have a plane perpendicular to it, which this was made from. And then you have another plane here, which is the area that the ball will shoot out of from. And so creating planes is super useful when you want to create 3D sketches like this, and also helps you fully visualize the very, very bare bones outline of what you want to do with your sketch, what you want to do with your assembly, I guess. And then from here, you can add the 3D components and make sure that you can add the 3D components and see like what materials you want to use, how you want to create it, all that. So this is the first thing you got to do. Most teams do this in the first couple weeks of kickoff. And now extruding boss space. This is where that 3D part actually comes in. So you have your sketch, and then you go into features on your toolbar and extrude boss space. And then you set a thickness to it. There are different types you can choose from. Usually I just do blind and set a thickness to it. We went with 1/2 inch here. And now you have a 3D part. It's not very hard. You just have to extrude boss space. And now holes. So when creating a hole, it's best if you have your main part already extruded and then you put the sketch of the hole on top. Because if you have them in the same sketch, it'll get a little messy if you want to change anything at any time. But if you have your whole sketch and your boss space sketch different, that'll help with making sure that things don't extremely change if you want to change a dimension to it. But oops, this is a little video on how to create a simple hole. So I'm going to orient it to the front and then go to sketch and start a sketch on top, select a hole and make a hole, and then I need to dimension it. And I just went for 3 inches, and then I go to extrude cut. So different ways, it doesn't show it in the video, but there are different directions that you can have your extrude cut go through. You have through all and up to next, or up to next surface. I would be very cautious if I chose through all, because if you have this part in assembly and you have a cut extrude through all, that cut will go through all the parts in the assembly. So one day you're just looking at the CAD and you're like, why is there a hole through all of these parts? And it's because you had this part through all. So you don't want that. I usually just use up to next so that I can avoid doing that. Oh my God, sorry. And then once you have that, then you set a thick, and then I just put up to next in this example, I think. And it goes through the whole thing. So yeah, that's how you make a hole. And then fillets. So fillets or fillets, it doesn't really matter however you pronounce it, but fillets are most useful when you have sharp edges you want to curve out, or just for aesthetic purposes. I don't use them very often, but when I do, it's just usually just to make it look better. And so we have, we go into features and then fillet, and you select the edges that you want filleted. And once you have that, you set a radius to it. Over here, you can set it to whatever you want. You put 30 degrees, 0.3 of an inch. And so now your object has a curve to it. Oops. Please. And then we have assemblies. So when creating assemblies, mating is the most important part. And so there are different types of mates you can do there, but I used coincident, concentric, and distance the most often. And coincidence is basically they're basically touching. It depends on what you're trying to get accomplished, but basically they're at the same level of, yeah, they're the same level. And then concentric is when you have two circular objects that you want to go through each other. So an example would be like you have a hole with a screw that you want to put in. So you would concentric for that. And then distance is when you know you want things a certain distance apart from each other. And so you set a distance for that. So here's an example of how to do a coincident mate. And here we have, this is what you see when you open up assembly. You have to insert your components. So search up whatever parts you want in your assembly. And then I chose an inner and back panel of a drivetrain. And once you have that, you can start mating. And that paperclip icon is for mates. And creating something like this requires 3 mates and all coincident too. So I made the top panels to each other so that they're at the same height. And then I want the faces to be perpendicular to each other. So I click that face on that side over there, and then the other face on that side. So now that they're perpendicular to each other. And now I finally need them to be at the same level like that. And so I just click the faces again, and now it's fully mated. Okay, and now concentric. Like I said, a screw and a hole is when concentric is used a lot. If you have any circle objects that need to be mated. So what you need to do is once you go into mates, you first do a coincident mate so that the head of the screw is against the panel. And then you click the circle in the hole and then the circle in the screw. And then this allows it to be a concentric mate. And you can also turn the screw as well. And then we have lastly your distance mate. This is when, like I said, you want a distance between your panels. And let's say you know that from the inner panels, you want it to be 18 inches apart. So you go into distance and then click the 2 sides that you want mated, and you set a distance to that. So let's say it's 18 inches. You set that, and now your panels are 18 inches apart from each other. And they also don't move either, so. Okay, and then mirroring mates. Mirroring mates saves so much time. This is an example of a drivetrain. All these parts down here, I already mated, and I just want to mirror that over. So what you have to do is first create a plane that is right in the middle of your entire assembly. And once you have that made, you go into insert a linear pattern component, you go into mirror, you select all those parts, and then just mirror about the plane. And simple as that, you saved literally hours of time by mirroring mates. And then custom off-the-shelf parts. So most, if not all teams don't custom make their bots. It's usually like they have custom off-the-shelf parts that come from McMaster, AndyMark, or Vex Pro. And McMaster, in all these companies, they have CAD files for all their parts as well, so that students can use them for their CAD. And I use these 4 a lot to either get reference to see what other teams. Well, GrabCAD's different, but these 3 websites I use to get CAD files for whatever I'm using. And McMaster is mostly for fastening objects like screws, nuts, hex shafts, stuff like that. And AndyMark I use to get CAD files of AndyMark specific products. And then VexPro is what I mainly use. That's where I go to find most of the products we use because my team likes to use a lot of parts from VexPro. And that includes like wheels, motors, and all that. So, and then GrabCAD. GrabCAD's something. It's a basically it's a sharing platform where you can share whatever CAD you have. So if you want to see what other teams did in 2020, you can search up 2020 robot FRC, and then some CADs will pop up of teams who uploaded their CAD onto GrabCAD, and you can see how other teams did their CAD that year and get some inspiration from them. And you can also download some parts as well. If you see that someone has a very nice custom made part that they uploaded onto GrabCAD, you can download that and use that in your CAD as well. And so these four places are really good for getting CAD files because you don't have to CAD every single thing. Motors, you definitely have to download from places like VexPro or AndyMark because there's no way you're going to be able to CAD that well enough like they do. And then drawings. Drawings are basically the last step. And you only need to use drawings if you want something custom made, because otherwise there's no need for it. And when you go into drawings, you first have to put out what each hole is or each side is, and each of them have a number in it. And then you have over here the distance between it, the lengths. You have to define everything so that people that are creating your part, whether they're water jetting it or laser engraving it, whatever it is, that they know the exact dimensions to what you want. And these enormous charts are also for the distance between each other. So all the parts are in relation to the origin over here. And so once you have all of that, people that are creating your part know exactly how to do it. And a lot of teams like to get their drivetrain panels custom made. A lot of people go to KSU because they do for free. They are partners with Georgia First. So if your team wants to create a custom drivetrain, KSU is a great place to go. Although I will also say that this whole thing is not necessary if the place you're going to doesn't require something like this. Sometimes they accept electronic files, and that makes it a lot easier. So you won't have to go through the pain of putting numbers to all of these and creating a chart to that. And it's just very simple. Okay, questions? Nadia, are there any questions?
Not at the moment, but we can wait a few minutes to let them roll in.
All right. It doesn't seem like there are any questions, so we can go ahead and end this session. Thank you all for coming.